Okay, so we're finally ready for one of the most complex initial challenges for us to get across, and that, of course, is going to be configuring our router. So things to understand. Right now, I've got my mini-hack infrastructure. My team number is currently 118. That's what I've tried to be consistent with, is using this 118 number, and I've already configured the IP addresses of my various machines to follow the topology. I've done a bare minimum configuration, and I have not configured anything beyond just getting the IP addresses online. So that's kind of my starting point. If you're not at if you're not at this point yet, maybe you should go and check out a previous video and make sure you get up to this point, because that's what I'm going to assume. I'm going to assume you've already got some of the IP addresses configured and whatnot, things we've done in a previous activity. So some things to understand when you want to configure a router. Number one, most of the magic is happening. Not all, but most of the magic is happening, of course, on the actual router device itself, on our CentOS machine. So this is the machine where I should have the 172.20 and the 192.168 adapter, right? And let's just go and take a look at it, right? So I'll clear off my screen here and type in IPA and confirm it's like, yes, I already configured the ifcfg files for ETH0 and for ETH1. Here they are. One of them is /16, one of them is /24. So it's connected to both sides. I'm connected to two different networks using two different adapters, the internal side and the external side. But the part that hasn't happened is the routing part. Routing has not currently been set up. And so I'd like to show one of the initial ways that you can go about setting up a router to route traffic from one network across an interface to another network. I'm not pretending that this is the only configuration technique that will work. There are other ways you can get there, but I'm trying to show, again, the bare minimums from the start. All right, and to just explore just enough information to get us something working, and then we'll continue to build from there. Okay, so what are things we want to understand from a routing perspective? The magic inside CentOS, a lot of this happens at the firewall. It's the firewall that's going to manage what are the rules about the networks I'm connected to, and who's allowed to go from one network to another, or more importantly, who's not allowed to do that. All right, and so you can check the status of your firewall using a command called firewall-cmd when you're on your Cent machine. So inside Cent, this is what I'd recommend learning, and all of the commands in order to do anything with firewall-cmd, or pretty much everything with firewall-cmd, you're going to need to have sudo. So let's give this a try. So I'll do a sudo firewall-cmd, and I think one of the useful things to take a look at from the start as you're understanding your firewall is to understand that your firewall has taken your computer and taken your current configuration and broken things up into different zones. So you can add on a bunch of options now to start getting information and changing the configuration. So let's first start by just getting some information and seeing the zones that have already been set up for us. And so we can do this through a --list-all-zones. You'll have a whole bunch of these commands in firewall-cmd. A whole bunch of these commands that they have multiple words separated by multiple dashes. They usually start with 2 dashes, and then every word from there is spaced out by a single dash. But you'll start to see some of the commands as you're using firewall-cmd. They're actually going to be quite long commands, but nevertheless, this is how we use it. So okay, let's give it a try, and we'll verify our password is password, and let's see what happens. It's like, oh boy, I just had lots of information, so much information that it went off the page. But we can start to see we've got some nicely segmented out sections. So why don't we try running the same command again, but let's pipe it now to less, so then I can see where the top of the output is and just kind of nicely scroll up and down through it. I'll pipe this information to less. And so now I'm at the very top, and you see one of the zones that's currently set up is called block. One is called DMZ, one is called drop, you've got one called external. We've got a home, we've got internal, we've got a public. Public currently has the tag of active. Okay, that's good to know. And then finally, we've got trusted. All right. Oh, actually, we've got work after that as well. All right. So realize that your firewall right now has one that it currently sets as the default, and that's the public zone. All right. And when you look at what has been applied to the public zone in your firewall, that tells you what type of rules and what type of conditions are currently being applied to the various network connections. And we can actually see underneath this is where our interfaces actually exist. The interface, ETH0 and ETH1, they both exist currently inside this public zone. And right now we are allowing the various services. So SSH. which means if someone tried connecting to this computer on SSH, this computer would accept an SSH connection. It also would accept a DHCP client request as well. So it's good to understand what are the default services that are built into the different zones and what zone are you actually using. All right. You can also start to look up and down through some of the other zones, and you'll see not every zone has the same defaults. Right? A lot of the zones are configured differently. That's why you have different zones. But you're not using every zone at the same time, in the sense that our ETH0 adapter and our ETH1 adapter, right now they're assigned to the public zone. So that's the zone that really matters, because that's where my network adapters are currently assigned to. And you can change zones. Maybe it would be beneficial to say, well, I don't want my ETH0 adapter to be part of the public zone. Maybe I want it to be part of a different zone. And because it is part of a different zone, you'll now have those sets of rules that will apply to that particular interface. So, but let's just understand this from the start, right? Let's understand we've got different zones. Your interface is applied to one of these zones, and all these different rules are now being applied to your interfaces based on that particular zone. All right, let's hit Q and kind of go back to our command line here. If you want to see just one specific zone, you don't have to do the list all zones command. You could say list all, list all space, and now simply identify the zone that you'd like to have this command run on. In other words, you could have a, let's say, --zone equals public. Now that we know there's these different zones, you can call the zone by name. So something like this will say, well, I'm not going to list all zones. I'm only going to list all the information about the zone that's assigned the word public. And so here it is. Here's the output to my zone equals public command. It's like, well, I got the ETH0, ETH1, and here's the rules that are applied to that particular zone. So very good to be able to understand you got multiple zones, but many times we sort of just focus in on maybe one zone or two zones, or only the zones that I actually have interfaces assigned to, because those are the ones I'm certainly going to care about from the start. Okay, great. So now that I see that we've got these different zones, and right now both of my adapters are in public, if I want to take on the task of creating a router, is this ideal? Is this good that both of my interfaces currently belong to the public zone? And the answer is, well, you could make it work. I mean, I'm not saying that it's right or wrong or good or bad. It's like, yeah, you could make it work. You could modify this particular zone so that you could set things up to be a router. And what I'm going to emphasize is, or recommend is that, well, maybe there's a simpler way. There might be a simpler way with fewer commands so that we're not going to use the public zone. We'll use some of the other zones that are currently set up, and those zones are designed to be used in the case of if you wanted something to be a router. All right, so let's see how we could go about doing that. Now, the zone that I'm interested in using in this particular case, there's actually two of them, will be the external zone and the internal zone. External and internal. All right, and that actually will be consistent with our diagram. We have a device that I want to be on the external side. I have a device I want to be on the internal side. And those zones are pretty well set up to be able to do the actual routing that I need them to be able to do. The settings on there they give us a half a step in the right direction. All right, so let's see how this will work. And so one of the things you have to learn how to do is, all right, I want to first take a look at what the settings are in the internal zone. It's like you can see here, it's like I've got the internal zone, but there's no interface applied to it. And we also have the external zone as well, right? Zone equals external. These are some commands that we're going to want to check in to see how can I get my interfaces to use the internal zone? How can I get my interfaces to use the external zone? I'm going to show two different ways, right? There's two different good ways that I'd recommend learning how to do if you want to take an interface and switch zones, if you want to apply an interface to a particular zone. One way that you could do it is actually to add the zone variable to the ifcfg file when you configure the interface in the first place. This is probably the quickest way. So if you remember back to when we were doing the initial networking configuration, maybe I'll do this with the ETH0 adapter. Right, well, we'll double check our networking. My ETH0 adapter is currently on the external side, right? This is the 172.20.118.1. And remember, this thing was configured. We did a sudo vi/sysconfig/network-scripts, and this was the ifcfg-eth0. That was the file that we initially configured to statically assign our address. Here it is, right? We added in the IP-ADDR, we added in the netmask. Okay, well, if you wanted to, you also could assign a zone right here inside this file. All right, so if we hit I to go to insert mode, you could come to the very end of the file, hit enter to go on to the next line, and simply say zone equals, what zone would you like to apply this one to? So if I have my external interface, I could apply it to the external zone right here, external. Right, all lowercase, that's what the zone was actually called, was the word external. I could say zone equals external right here as I go and configure my interface. This is pretty easy. Pretty easy to be able to do. You can configure your IP address, configure your netmask, add the zone right in there. And then we could save this, right? I could hit my escape and then :WQ. And has the change been applied, right? Let's check our zones. Has the change actually been applied? If I look at the external interface, or excuse me, the external zone, we see there is no interface there yet. It's like, well, you made a change to the configuration file, you got to restart the service. All right, so that would be one way. We could do a sudo systemctl restart network, right? It's through the network file. That's what's managing those ifcfg files. And now if I check my zone equals external, you'll see it now has the ETH0 interface that's been applied to it. And now the rules that are associated with the external interface, those are the ones that are going to be used specifically for the IP address that's currently on my ETH0. So that means externally on the 172.20 network, I am still accepting incoming SSH connections. I could SSH to this particular address. That's what the services means. All right. Whereas before we were accepting SSH as well as the DHCP connection. All right. So we're slightly more restrictive now because that particular service is not currently being allowed for incoming requests. All right. We'll also start to notice here that actually the masquerading is also different. Masquerading currently says yes, and we'll get to that in just a second, but that's actually a really critical thing about the external zone. The external zone is the only one that currently has by default masquerading already set to be yes, which will be very useful when we're looking to configure a router. So that's one way you could assign an interface to a different zone. All right, they all come with the public zone by default. You could end up moving them around, and that's what I'm recommending here for a router. The other way that you could do this, the way you could move it, is actually by using a firewall-cmd command. So I think it's pretty easy to put it right there in the CFG files, but I also want to show a little bit of practice here using more firewall-cmd command. So how could I use a firewall-cmd command to change the zone of a particular interface? And the answer is, well, there's a --change interface command. You could do --change interface, and then you would have to specify equals ETH1. So what's the interface that I'm looking to change? It's the ETH1 interface. Okay, where is it that I'm looking to put it? It's like, well, I want to put it on --zone equals internal. All right, so I'm specifying the ETH1 interface, and I'm specifying zone equals internal. So I'm not going to do a list all, I'm doing a change interface. Now here's a really critical command that we want to understand, or a really critical option with firewall-cmd, and that is the --permanent command. When you run any of your commands, or pretty much any of your commands, other than like the list all command, any command that actually changes something, most of your firewall-cmd commands, when you run something that actually changes the configuration, it will change it immediately, but your change is temporary in the sense that if you restarted the computer or if you restarted your firewall, if you restarted that service, the change would be lost. It's kind of like adding in a temporary IP. You didn't put it in the configuration file so that it would persist from restart to restart to restart. So we want to make sure that we're making changes that can actually survive a restart, in which case, let's make sure we add on the --permanent option. The reason why you might not want to do the permanent option is because what if you were just testing something out? If you tested it out, you'd be able to see, is it actually working the way you wanted it to? And if it wasn't, you could simply reload your firewall, and then anything that wasn't permanent would get removed. The downside to using permanent, here's the downside. The downside to using permanent is that it doesn't get applied automatically. So if you don't use permanent, it gets applied right now, but it doesn't survive a restart. If you use permanent, it doesn't get applied until you restart. So it's something we'll get in the common habit of is I recommend use permanent, but you made a change, so we'll have to reload it to actually have the change applied. So let's give this a try. We'll actually run this command. I'll add on the dash dash permanent. You hopefully should see a little message here that says the interface now setting zone to internal, and it says success. Okay, hey, I like when it says success. Success is good. But if we go and we actually check the internal zone now, right? If I do a list all on my zone equals internal, this is where we'll see a lot of times these types of changes, they don't happen automatically, in which case I want to emphasize it's good to learn how do I restart to have my changes actually get applied. All right, so if you ever have something that you need to restart to make sure it gets applied, you oftentimes have this sudo firewall-cmd, and then you would do a dash dash reload. Now we saw that this particular change, this happens to be one of the few changes that this one actually gets applied before we do the reload, even though we had the dash dash permanent option. But it's a really good thing to do to make sure your changes actually survive a reload. Right? If you do a dash dash reload on your firewall, anything that's permanent should still be applied. But if you had things that were not permanent, those are not going to be applied. All right, so now we've taken advantage of the fact that we have an internal zone and an external zone, right? I'll kind of take a look at both of these sort of simultaneously to see. I've got my ETH0 on my external zone. I've got my ETH1 on my internal zone. And now the rules that are currently applied to those zones will be able to help me out. Now you'll see on the internal zone, I actually have a couple other services that are currently enabled. It will accept an SSH connection. It'll also accept a Samba connection. We still have our DHCP connection. So learning about what these services are will be useful to know, do I want to have this service or not? And there are some commands to be able to add a service that would allow an incoming connection to the computer on those default ports, right? We've got our default ports for our SSH and for our DHCP. You can go kind of look those up. Default port for Samba connections. All those things are good. Okay, now for our particular example, one thing that we're really trying to do is work towards setting this up to be a router. And I kind of hinted at earlier, the thing that's really useful about using these zones, using the internal zone and the external zone, specifically the external zone, is that masquerading is already enabled. Masquerading is set to yes, whereas on the other zones, masquerading is currently set to no. So it's one fewer thing that you would have to configure from a routing perspective. Now, what masquerading will allow you to do is will allow your internal devices to actually use this as a router and go out to the external network. So right now, we're kind of configuring the router, and we want two things to happen. I want traffic from the outside to be able to come in to be able to see my website. I'm also going to want any of these internal devices to use this as their gateway so that they can get out to the external side. And that's what the masquerading helps with. The masquerading will help with any of these internal devices that want to try to get out using the router and see something on the outside. They'll be able to do that if masquerading is enabled. If masquerading is disabled, they're not going to be able to do that. And that's something where you'd have to run an additional command. And again, you guys can just wander your way off to Google, go look up some firewalld commands, look up firewall-cmd, and you'll learn there's a way to add masquerade to a particular zone or to remove it. And that's how you could change this from no to yes or from yes to no. But hey, it's already been done. So now I have one fewer command to be able to do. The other big thing that I mentioned, I want the website traffic to be able to come in from the router from the external side. Okay, so let's see what will happen in order to do that. So what we want to be able to do from our diagram perspective is anyone on the outside, if they visit the IP address of the external, right, they're going to visit the 172.20.mynumber.1. If they visit the external side, what I really want to happen is I want that request to go to my website. So someone could request my router, hey, I'd like to see your website, and that will be passed on to the internal web server. That's a lot of how our web servers behave. They're hiding behind some router. That router firewall is acting as a layer of protection so that you don't interact with the web server directly. You're actually being kind of filtered through some router firewall for added security. Now, this particular command is what we would call a forward. So we're going to get a request on the outside, and then the request will get forwarded to the inside. All right, that's really important to understand. And I see a lot of people kind of screw this up because they think that they need to add the service. Adding a service means you could connect to that device. Adding a forward means it will take the request and pass it on to another device. So what you don't want to do in many cases is you don't want to add a service, HTTP or HTTPS, to your router. Because what that would say is, well, the router itself is running the web page. And that's not what we have. Right now, the router is not running a web page. It's my internal Ubuntu machine is running the web page. So if the request comes in, I want that request to get passed on to the web server. I don't want it to try to go to some website that currently exists on this computer. Well, in this particular case, it doesn't exist. All right. So we're going to add a port forward. Okay, not enabling a service, but adding in something that will forward the service on, or forward the request on. Okay, now this is a bit of a long command with a lot of tiny little details in there, but let's see what it looks like. Okay, so I've got a sudo firewall-cmd. Now that I've moved these zones, masquerading is enabled. I currently don't have a port forward, but this is going to be a very useful one to do. What zone am I adding this to? It's like, well, I've got --zone equals external. That's the zone that I'm trying to make this particular change to. And you have this --add-forward-port. And this add-forward-port command starts to get a bit long. And actually, it'll probably go off my screen and my camera might get in the way. So I'm going to press Control-L just so it pops up to the top of the screen there and you guys can actually see the whole command. All right. So I've got this --add-forward-port. And here's where we can start adding in some of the details of what exactly do I want to forward and where exactly do I want to forward it to. Okay, so lots of details. Stay with me here. So we've got an equals. So add-forward-port equals port equals 80. So we're specifying I'm going to add in a port forward, and I'm specifically forwarding port 80, which means if I get a request on port 80, that's traffic that I'm actually going to look to apply to this forwarding rule. I'm also going to say maybe I could, you could also specify something like the protocol. So I could have a colon and then say proto equals TCP. So that would say if I get a TCP request on port 80, we'll forward it. Maybe you'd want to forward TCP. Maybe you'd want to forward UDP. Maybe you'd want to create a forward rule for both, where you do both TCP and UDP. But for this one, I'll say let's just forward in TCP to start. Okay, what else could I forward? I could also do a to port. I've got a colon and then to port, which means if I get the request on my port 80, you do have the ability to send it to a different port internally. It's like, well, I definitely don't want to send it to a different port. My website internally is also listing on port 80. So I'll say to port also equals 80. So I'm kind of keeping the consistency there, but it does allow you to actually go through and modify this. So you could listen on one port externally and listen on a different port internally, and the forward rule is what actually connects the two. Okay, and then finally we've got another colon, and now we'll have a to ADDR, as in to address. So this is where if you get a request coming in, you have to specify what ports you're forwarding it to. You also have to specify what's the IP address. And of course, the IP address where I want this to go internally is 192.168.118.2, right? If we refer back over to the diagram, it's on the diagram, that's the IP address of my website. So an external HTTP request gets forwarded to a port 80 on this internal web server. That's the goal of this particular command. And if you want this command to last, to survive a restart, you have to toss in somewhere, you have to toss in that --permanent option. All right, so that's one of the port forwarding commands that we're going to use to be able to forward our services. And this requires you to know the port. If there was a protocol restriction for TCP as opposed to UDP, you'd have to specify that. And you'd have to know where's your server to be able to forward it internally. And I specified my zone. My zone, this is not getting applied to all my zones. It's specifically getting applied to my external zone. All right, let's give it a try. Let's see if that works. Did I type everything out correctly? I'll verify my password again. Whew, and it said success. Did the change get applied yet? Right? If I hit a couple up arrows and I try checking my list all zone equals external, you see, nothing has changed in this case. I don't actually have the port forward yet because I had --permanent. So this type of change does not apply until you do a reload. But if I restarted the computer and I reload things, the change will survive all that stuff. So that's what I've set myself up to do. So we'll have to do a reload. Sudo firewall-cmd --reload. And now hopefully everything goes and reloads correctly. And now when I check my zone equals external, you see now I have a port forward. All right, so I've got my ETH0 on the external zone, masquerading is enabled, and I'm forwarding incoming requests to the web server. Are things working yet? Maybe we'll take a look. We'll see. If I get a request on the outside, is it working yet? Is the scoreboard actually going to be able to read and see? Oh, let's hit the scoreboard button. We'll see. It's like, huh. I have a port forward, but things aren't quite working yet. What's not quite right about my configuration? So, really common thing that a lot of people screw up when they're configuring their routers is, yes, you successfully created a port forward. Yes, you successfully enabled masquerading. However, you never configured the server itself so that it can find the way back out. In other words, you did a base configuration of your service, but the service itself doesn't know how to find its way back out to the external network. And the way that we do that, of course, is by setting up gateways. So that's why your computer has a default gateway. If it ever needs to find its way back to some external network, it takes the request and says, well, let's pass it on to the gateway. All right, so that's something that has not been configured on the website, right? If I go back to my diagram, when I set this stuff up, all I did was put in the IP addresses. I did not set any gateways on any of these machines, either on the internal Kali or on the internal web server. So in order for the web traffic on the web server to find its way back out, you need to put in a gateway on the web server. So the gateway of the web server should be the internal IP address on the router. So if a request comes in, it'll get forwarded to the web server. And then when the web server wants to respond, it can send it back to the internal address on the router, which then using masquerading will forward it back out to the external side. So that will be one of our last steps here to double check. Let me go over to my Ubuntu machine here. Oh, let's make this one kind of go full screen so we can see it a little better. And from here, let's log in and check our networking configuration. And remember, on our Ubuntu side, this is where we were using the Netplan file, right? So I had that sudo nano /etc /netplan and then there was that 01-network-manager-all, those .yaml files, right? Those were the ones that we were configuring this with. So I set up the interface to have an address, but I did not set up the interface to say this is the gateway you should use in case you have a request that needs to leave the network. All right, so that's what I'm going to do. I'm going to add in another line, and I'll keep the spacing right underneath where I added in addresses earlier. And I believe the syntax to be able to do this is to type out gateway and then a 4. Gateway and then a 4. And then you could have your colon. So this is a way I could set a version 4, IPv4, a gateway for this. And what's the gateway I want to use? It's like, well, what's the internal IP address of my router? We've got 192.168. For me, it's 118, and then that's .1. That's the IP address that's currently set to be the internal side of my gateway. Let's give it a try. If I do a Control-X-Y enter, let's see if I've got my syntax correct. I'll do a sudo netplan apply to be able to apply my changes. All right, my IP address shouldn't have changed. My IP address is still 192.168.118.2. My website should not have changed. If I try reloading the website, oops, I might have to restart my web service. That one might actually need to be restarted because I just changed my IP address. Let's try restarting that. Sudo systemctl, I'll restart my Apache service, and then hopefully it'll take my new IP address. Let's give it a try now. Now if I try loading it up, okay, everything's good there. I just needed to restart my web service. All right, so all the information, all those files are still there. That hasn't changed. The hope now, though, is that the gateway is actually being used, which will allow external requests to go back out to my scoreboard. All right, so how can we give it a try? It's like, well, maybe we'll take a look over at the scoreboard and we'll see, hey, we've got some green. All right, so what that means is that the router was actually able to be found. We were able to bring our router online. The web service is running on the correct IP address, which means if someone accessed the external side, it actually found a web service, and the content was correct. Remember, you had to set the content to be your team and then your actual team number. All right, so we've kind of met all the requirements of the mini hack by configuring a router to forward traffic through to the router and then allowing this traffic to find its way back out using masquerading. So masquerading had to be enabled on the external side, and that's why we use the external zone, because then I didn't have to go and change that and set that as a particular setting. So, and that's a really common thing. A lot of people, they forget the gateways. They lose the gateway and then their traffic doesn't know how to find its way back out of the network. One thing that this also might give us access to is now that this internal machine has been configured to have a gateway and use a routing path, you could actually start accessing things on other networks. So I could try accessing the scoreboard here directly, right? What was the IP address to the scoreboard? It was that 172.20.0.1. There was no direct path before for my web server, my Ubuntu machine, to reach the scoring server, right? It's on a different network. But now that I have a gateway using a router, using that masquerading, now I should be able to reach my way out. So if I do a 172.20, let's type back in the score bar, 172.20.0.1, we'll see it actually loads up the scoreboard. Now it gives us an HTTPS warning because we've got a self-signed certificate for the login. That's okay. You can just say advanced and say accept the risk and continue. I know it's just our scoreboard. We're not getting hacked or anything like that. But it's like, hey, I could actually visit something on another network because my routing was working. Is this working currently on my Kali machine, on the internal Kali machine? Right? If I come over here to my internal Kali machine, this one was brought online, but if this one tries visiting the 172.20.0.1, you see you can't find it. And what's the problem with this machine? It's like, well, it has the network connection, but it doesn't have the gateway. If you don't tell your internal devices what's the gateway to connect to, if you try going to another network, it won't find the path. So yeah, you'd have to go through and add in the gateway variable to these particular devices. And many times, of course, the word that you're looking to add is just gateway. In the Netplan one, you had to add in the gateway 4. That was the actual variable, but maybe we'll try it here quick. I'll do a sudo nano /etc/network/interfaces. All right, and I'll modify this file to say, all right, I don't just have an address and a netmask, I also have a gateway. And my gateway will be 192.168.118.1. So as you get more networking details that apply, you can go and start adding them into these files. If you don't actually have a gateway, it's like, well, then you don't need to configure one. I could do a sudo systemctl and then restart my networking. Let's give that a try. Okay, I've restarted my networking, and now if I try loading up the page, I'll probably get that same issue. Okay, yeah, I was able to go and visit 172.20.0.1. All right, and I can confirm that everything is working. So gateways are really important, but you need to have a router available to be able to do that. And I'll kind of give maybe one last little example here. You notice the external Kali, this one didn't actually have a gateway, because this one was connected on the external side. So there is no router out here to connect to go connect to some other network. That's the difference between an external as opposed to the internal. So it's okay that this one doesn't have an external. Not every device is always going to have a gateway. It's only if there's some other router it could connect to go viewing things on the outside. Something we could also, though, configure or kind of confirm here, this is what the scoreboard sees. The scoreboard is trying to visit the external side of your router, and it's loading the page from the internal. So we could actually test this now on the external side. On the external machine, which is what I'm on right now, I could try visiting 172.20.mynumber, 118.1. Right? I'm going to try visiting the external side of the router. I'm not going to go to the scoreboard. I'm going to go to the external side of the router. And when I try visiting that, you see my traffic got forwarded in. I got forwarded in now to the Ubuntu machine. So I now have a path through the router only on port 80 to port 80. So sending traffic in from port 80 to my internal web server, and then it used the gateway to find its way back out to the external Kali. And that's, of course, that's what the scoring server is doing as well. It's checking to see, can I go to the router and actually find your internal machine, and does it have the correct content? And, you know, it's like, woohoo, we got there. We were actually able to configure a router. We were able to configure our web server, and this is what kind of concludes a successful configuration of your initial mini hack. This is kind of a microcosm of the real event. The real event, you'll have a lot more configuration to do. You'll have more complex services. You'll have more complex requirements. You'll have other things to do. And of course, you'll have a live red team attacking you. You'll have a contested force that's specifically trying to go in and screw with your stuff. And so you'll have to apply a lot of your good security practices. You'll have to make sure you have backups of things and learn about services and try to figure out what are the ways that they're breaking into your stuff, and definitely doing remediation to be able to fix things. So, but to kind of summarize a lot of the routing stuff, you can kind of see here, if I do a quick history command, you can kind of see, hey, we've got a bunch of these firewall-cmd commands that are really, really useful to learn about. Learning about these forwarding ones is also critical as well. You'll have to forward in multiple types of traffic. learning about turning on masquerading, turning off masquerading as necessary. That's what allows the traffic to find its way out. And then also learning, like, some of the shortcuts, of course, is you can put some of this information right there in your ifcfg files. So if you put the information right in the ifcfg file ETH0 and ETH1, it's like, well, then you could just restart your networking. Your zones are already connected. You could add in the port forwarding, restart your router, and then your router is good to go, at least with one simple service. But learning about different things, learning about different services, definitely you could spend a lot of time doing more firewall commands to be able to do that type of stuff. So, okay, great. We'll continue on with other services in future videos and be able to continue to expand our knowledge. But at least this is enough to get us across the finish line for our initial mini hack. Great.